Now, students of class 9, today we will learn about equations of motion by graphical method. How we can prove equations of motion by graphical method. That will be very important topic in class 9, and we should know how to derive equations of motion with the help of velocity time graph. This is a major topic of our discussion, and we should know this in detail because in the examination also this topic comes, and if we know, it will help in our understanding. So let us learn equations of motion by graphical method. Equations of motion by graphical. There are three equations of motion. Three equations of motion we have to prove. We have to derive. Three equations of motion we have to derive. And how we are going to derive? We are going to derive three equations of motion by graphical method. And for that matter, we will use velocity time graph. That is very important. Velocity time graph. So our topic is equations of motion by graphical method. By graphical method. Equations of motion by graphical method. For which type of motion? Motion in a straight line without changing direction and also uniformly accelerated. Motion in a straight line without changing direction. Motion in a straight line without changing direction. Motion in a straight line without changing direction. And also uniformly accelerated motion. Acceleration is constant. Acceleration is uniform. So acceleration is constant. Acceleration is uniform. Okay, we will use velocity time graph. That will be also speed time graph, because this type of motion, when motion in a straight line without changing direction, speed time graph and velocity time graph is same. Or it could be also known as speed time graph. It is also known as speed time. If you remember the graph, the last day class, what we have drawn, last day class we have got the velocity time graph. This is x-axis where we take time, and this is y-axis where we take velocity or speed. So initial velocity, maybe we were getting a point that a vehicle was there and at time is equal to 0. Observer observe the speed u or velocity u, initial velocity is called initial velocity, and after some time t, velocity became v. So how this change taking place? Due to acceleration, a. So here we will draw this observation in graph. X-axis we will show time. This point, if you remember, this point was a. This represents velocity u at time 0. At time 0, velocity u. This was our first data. The point A gives you the first data. Then time passed, and after some time, maybe t, what happens? The point here represented by maybe d. D point represents that at time t, velocity was v. So this point B represents that. At time t, velocity v. So we are getting these 2 points sufficient to draw a graph, velocity time graph, and we are joining AB. AB is the velocity time graph or speed time graph. Okay. Now, if you remember, I gave you last day the idea that slope of this velocity time graph gives acceleration, and to derive first equation of motion we will use this concept that slope of velocity time graph gives acceleration. So how we will find slope? For that matter, we draw parallel line OD. We are representing this a parallel line. Okay, you can name it C, AC parallel to OD, and this angle very important because slope is tangent of the angle. Maybe if this angle is theta, then tan theta slope. If you don't bother tan theta, then slope means perpendicular BC by base AC. This we have to keep as slope. So in this right angle triangle ABC, slope means perpendicular BC divided by AC, and slope gives acceleration also. That is our point. So to find BC, what we have to do? This is, you can name it E point here. So OE equals to BD. This is V, so this will be also V. OA equal to CD. This is U, so this will be also U. So to get BC, what we have to do? BD minus CD. BD, V minus CD. So BC will be V minus U. Last day also we have done this. So this concept we are using again to derive first equation of motion. If in the examination question comes, you have to do like this, because Example says that question, generally this is very important topic, also important question also. Motion in straight line, this question, this topic, very important. From where this equations of motion come? So any equation is a relation. What relation? The first equation of motion, if you are talking, first equation of motion is a relation between what? First equation of motion. Actually, first equation of motion is V is equal to U plus it. V is final velocity, U is initial velocity, A is acceleration, T is time. Okay, this we have to prove. And for that matter, we are using this graph. So certain description we can write in a language also. Okay, let us consider an object moving with initial velocity u, at time t is equal to 0, and after some time the velocity becomes v. Okay, then AB represents speed time graph or velocity time graph, and slope of velocity time graph gives acceleration. So we can say, so acceleration A of the object is given by slope of velocity time graph. Okay, this is the statement we have to give, very important. As shown in the graph, slope is perpendicular BC by AC. In right angle triangle ABC. So in right angle triangle ABC, we are getting perpendicular by base. Now we are putting the value BC. BC means BD minus CD. AC means OD. And now we can put the value, and slope of VT graph gives acceleration. So we are getting here cross multiplication AT, and then V minus U. Minus U, you bring this side, you will get plus U. So you are getting finally V is equal to U plus AT. You can see this is first equation of motion proved. V is equal to U plus AT, first equation of motion proved. So similarly, if we don't forget the steps, the first step is to draw graph nicely, to give the points of the graph. That will be, don't do experiments. You remember origin O, and then A point represents that at 0 time velocity is U, initial velocity, 0 time velocity is U. This represents represented by point A. And then at time t, the velocity becomes v. So B point represents that at time t, velocity is v. So this is actually t time velocity v. And we are getting 2 points B and A connecting, we are getting graph. Okay, so you remember, and rest of things you know how to go through. So now next, second equation of motion we are going to prove. Second equation of motion is S is equal to ut plus half at square. So let us prove now. S is equal to ut plus half at square. S is equal to ut plus half at square. second equation of motion. So how to prove second equation of motion? For this, one concept is very much required. That is also one important point of velocity time graph. Last day also I discussed this point, that area of velocity time graph, area of under velocity time graph, that means AB is velocity time graph, and whatever the area, that means this whole area with x-axis, what it makes, that means area of OABD. This is area under velocity time graph. So when we talk about area under velocity time graph, that means AB is velocity time graph, and with x-axis whatever area it makes, you can see area OABD. This is the whole area. We can break it into a rectangular area and a triangle area. Okay, so these are 2 points we should mention here. Actually, the graph, when we call it, then we remember that velocity time graph. So we can write here area under velocity time graph. Second equation of motion, that is S ut plus half at square. S is equal to ut plus half at square. This is second equation of motion that we have to prove. Second equation of motion is very important. S is distance or displacement. U is initial velocity. T is time. A acceleration, and again T time. So for this, one theory is very important, one concept is important. That is distance travel or displacement. So area under velocity time graph gives displacement of the body. Displacement S of the, that means displacement of the body, okay, is equal to area under VT graph. Displacement is S, area under means OABD, area OABD, that is area of a triangle ABC plus area OACD. So this is a rectangle. Okay, you can see OACD is a rectangle. So rectangle area will be what? Length into breadth. So this is length T and breadth is OA, that is U. So OD, that is T into OA. OD into OA. OD into OA. So OD into OA, we will here say OD into OA. Here area of triangle ABC, half into perpendicular BC, we can see here, okay, perpendicular BC, that is B minus U, and base AC. So half into BC into AC. We can put the value. So what is BC? BC is nothing, it is B minus U. It is B minus U. And what is this? This is T. Okay. Because AC is equal to OD. That is T. What is OD? OD we have got T. And OA is U. So UT, this side we are getting UT. And here what we are getting? Half B minus U. Now in the place B minus U, what we can write? From the first equation of motion, you remember, first equation of motion, V is equal to U plus AT. This is the first equation of motion. If you are bringing this side, you can get minus U. So in the place B minus U, what we can write for first equation? AT. So finally, what we are getting? Half AT into T, that is half AT square. So half AT square. This is UT. So finally we have proved S is equal to UT plus half AT square. This is our second equation we have proved. So proved. So let us try to understand once more what we have done. This is second equation of motion we have done. Let us try to understand once more. Here, actually, one more concept of velocity time graph that we have used here. One more concept. What? Concept is very simple. Area under velocity time graph gives displacement or distance. So, displacement is area under velocity time graph. What is area? Area means this area, whole area. Whole area. So that is combination of a rectangle area and a triangle area. So area of a triangle plus area of rectangle. So rectangle area is our what? Length into breadth. And what is triangle area? Half into perpendicular BC into base AC. So this is our starting point that we have used our basic concepts of geometry, that how we can get area of a triangle and area of a rectangle. And then we are putting all the datas and we are getting second equation of motion proved. S is equal to UT plus half AT. So this important topic we have learned, and we will get in another video third equation of motion also proved. So these things are very important concept. In this chapter, motion in a straight line, graphs and method of graphs to prove equation of motion is very important. Once we will prove all these three, we can use it for numerical problems. So motion in a straight line, motion in a straight line, very important topic for numerical, theoretical, examination point of view, for competition or for any examination. Okay students, thank you everyone.